All right, I'll start from here. Okay, thank you guys for joining us for the second session of the rotational update of the work streams. I will be sharing updates from Cooling Workstream on behalf of the members of the group, and later I'll pass to Wei to give an update on the OAM2 workstream. So a brief introduction of our workstream to reiterate our goals. We want to establish the specification, frameworks, standardization, and best practice of advanced, especially liquid cooling solutions for OAI systems and OEM products, including module level all the way to system level. Out of the L10 level, that's not part of our scope. In the past, we have released a bunch of design guidelines, reference designs, and we have demonstrated multiple prototype systems from Baidu, from Meta. And in 2021, we have been focusing on the analysis and prototype practice of single-phase liquid cooling solution to support OEM up to 1,000 watt level at module level. In 2022, we'll be further advancing those technologies for better performance, efficiency, and sustainability. Also to call out, I'm just coordinator of this workstream, and the direct content of the slides are contributed by Dennis from Microsoft, Alan from Cooler Master, Jalen from Weaven, and Chris from Boyd. We have other active members in the workstream, Baidu, Intel, Habana, Inflame. You will see their contributions in the future white papers and other publications. Yeah, in the OAI training cooling space, there are several challenges we encounter. Of course, there will be more down the road, but the three major things we notice is foreseeable OEM power demand growth. Like you can see that in the OAM 2.0 highlight, we are aiming at delivering 1 kilowatts at module level. Second, we were likely to see more compact module level and system layouts that will put a lot of restrictions on our thermomechanical design. Lastly, across the spectrum of users and system designers, you will see a huge variation of boundary conditions and design philosophies that complicates the user scenarios and deployment considerations. So we cannot solve those problems at once, but we are in progress to solve some of them. Right now, the ongoing efforts including establish the basic user requirements and interface guidelines. Also, we're performing the prototype practice on the 1 kilowatt level thermal-test vehicle and cold plate solution design. We're evaluating a system level solution from multiple perspectives, and in the end, you will see a white paper published to conclude the outcomes as the guidelines for OEM liquid cooling. For content related to other technologies, such as extending L cooling, two-phase liquid cooling, or even, let's say, some more advanced technologies, those will not be released anytime soon, but we're definitely looking at them in the future. A little bit into the prototype practice at very high level, we are focusing on directly the thermal-test vehicle delivering 1 kilowatts. Following the UBP 1.0 layout, which is a legacy layout, and you will see newer versions in the future, we are evaluating that up to the 16 liters per minute at system level. The target of these efforts are trying to study feasibility of single-phase liquid cooling on the high-power OEM products, quantify the impact of general design parameters, and lastly, practice system-level design for serviceability and robustness. This is a very simple scheme of the layout, and notice that there are several versions of the prototype systems, and you will see something differently on our booth, which reflects an earlier design based on the Meta Xeon system. This is a 4x2 design, which is a traditional flow network, and have internal manifolds supplied return to pairs of manual QCs, designed for up to 8 kilowatts loading in the system level. Those efforts are ongoing, contributed by Weaver and the Cooler Master, and you will see more detailed publications in the future. And right now, based on the study results, it has shown pretty good outcome to support the upper limit of the OAM 1.0 power, and then some conditionally supporting the OAM 2.0 power with cavities, of course. Further into the more aggressive designs, we want to examine, okay, what's the best outcome we can get with single-phase cooling. So definitely changing the flow network is in the picture. Boyd has been studying this for a while, and right now the study is showing that it has given us quite good performance with promising flow distribution. Of course, such study design is looking into the trade-offs between flow rate, distribution, pressure drop, and temperature uniformity. You will see more outcome from this group in the future. So since activities like this are ongoing, and there'll be more and more down the road, but what we want to share here is that although we are trying to tackle those detailed engineering problems, provide guidance for general users, suppliers, and designers, there are always things there are always complexities we cannot fully explore. There are always other optionalities we cannot fully examine, and we really want to see more participation from the community in those areas. If you think your product could be affected or your customer could be affected by those topics, by those outcomes, guidelines, specifications, please feel free to reach us and join us in those efforts to figure out a better foundation for everyone. You'll see our contact information at the end of the slide. Yep. Next, I will hand it to Wei to the OAM2 update. Thank you.
Thanks, Chen. Hey, everyone, this is Wei. I'm a software engineer at Meta Infrastructure. I'm going to spend a few minutes to talk about OAM2 update. This is kind of a software project, work group that we have initiated last year. It's kind of different from a hardware space. But the overall mission of the OAI is to really create a open, modular, and hierarchical infrastructure to be able to allow different accelerator modules to be interoperable, right? And the OAM is really a common form factor for different accelerators so that they can be interoperable. And however, deploying these OAMs in the hyperscale data centers still present challenges. And one of the biggest challenges is each of the OAM, even though they're common form factor, they still use a vendor-specific tool, right? So this is not really truly interoperable because we have to, in terms of Meta's deployments, we have to use different tools for different hardware modules. And the OAM2 is really created in that context. This work group is to build, the mission of this work group is to build a common utility that is vendor agnostic and also open source, that is capable of managing the different OAMs from different vendors. So at the core of this task group is really to define a OAM2 API specification. And this is what the group is currently focusing on now. And we want to define a common features that be able to manage the OAM modules. And we also define a software architecture that includes a common framework for the APIs and also vendor-specific plugins in the form of a dynamic loading library to be able to manage each vendor's specific modules. And one thing I want to clarify is we are not defining a communication protocol between the host and the OAM modules. This is not our scope here. Our scope is actually recognizing the difficulties in doing that is to elevate the effort one layer above. We actually define the APIs between the host and between the libraries, the host side software and the libraries. So it's up to the OAM vendor to decide what communication protocol they're going to use. And so some of the update on the specifications, and we are almost close to the first version, finishing up the first version. And we are focusing on hardware management, monitoring, and diagnosis, and module discoveries, topologies, health checks, and firmware downloads, firmware management, stats, and telemetry. So our goal is to hopefully submit the spec to OCP at beginning of this year. Beginning of next year. I have to mention there are actually more vendors, users, and joining the group. So it's good. Hopefully, we'll have something useful to demo next time around at the OCP Global Summit. And with that, I think it's call to actions. You can reach out to Jen for cooling, for the tool. You can reach out to me for anything else. I guess you can reach out to Whitney, and she's going to direct you to the right place. Thank you.
Thank you so much.